Hello everyone, welcome back to my channel NCERT Maths with Bardeep. Today we are continuing our exercise 3.5 of chapter 3, that is pair of linear equations in two variables of grade 10. Second question is, for which values of a and b does the following pair of linear equations have an infinite number of solutions? So this pair is given to us. Again, this is very important type of question. This will come in your exams also. So now this is our given pair and we need infinite number of solutions. So whenever we need to find such values, first thing is right hand side should be 0. So let's make it 0 first. 7 will be shifted, so minus 7 equals to 0. Here it is a minus b times x plus a plus b times y. So now see, this full is our right term. So better is put this in bracket before changing the sign. So minus this full term should be put in bracket. Otherwise students make few mistakes in changing the sign. So better is take this full term as 1, put in bracket and then only shift to left hand side. So now second thing is we should find their ratios, that is a1, a2, b1, b2. So let's write first. So here what is a1 and a2? a1 is 2 but b1 is a1 is 2 and a2 is a minus b. Next thing is b1, b2. So here b1 is 3, b2 is a plus b. So everywhere I am putting brackets so that there is no confusion. Now is C1 and C2. Okay. C1 and C2 is minus 7 and this is minus of 3a plus b minus 2. So now second thing is, for infinite many solutions, what is the condition? a1 by a2 should be equal to b1 by b2. Further should be equal to c1 by c2. So first find these ratios. a1 by a2 is 2 over a minus b. b1 by b2 is 3 over a plus b. And then c1 over c2 is minus 7 over minus 3a plus b minus 2. So now what should be our next step? That these ratios should be equal for infinite many solutions. So we will write for infinitely many solutions, these ratios should be equal. So we will write a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. So what is a1 by a2? This is 2 over a minus b should be equal to b1 by b2, that is 3 over a plus b, and this is equal to minus 7 over minus 3a plus b minus 2. So now this can be cancelled. If you want, how to solve this again? So again, since we have three different terms having a plus b or a minus b, then we will take our first two things, okay, these first two terms to frame one equation in a and b, and then take second and third to frame second equation in a and b, and then we will solve them. So now let's take first two terms. So these two terms, this implies 2 over a minus b is equal to 3 over a plus b. Okay. So cross multiply them. This is 2 times a plus b is equal to 3 times a minus b. So now open these brackets, that is 2a plus 2b is equal to 3a minus 3b. Right? Shift a term to one side and b term to second side. So 2a, this 3a will be negative on this side. So minus 3b, this 2b also goes to other side with negative sign. So 2a minus 3a is minus a. Minus 3b minus 2b is minus 5b. So here we are having one equation. See, a is equal to, this minus and minus will be cancelled. So a equals to 5b. This is the first relation in a and b. Now let's use second and third to find second equation. So let's take second term, that is 3 over a plus b equals to 7 over 3a plus b minus 2. Again cross multiply these values. So first 3 into this thing, that is 3a plus b minus 2 should be equal to 7 times a plus b. Right? Open these brackets. So 3 into 3 is 9a plus 3b. 3 into 2 is 6. So 7a plus 7b. Shift a and b to one side. So this will be 9a plus 3b. On this side minus 7a minus 7b minus 6 equals to 0. So now let's combine the like terms. 9a minus 7a is 2a. Plus 3 minus 7 is minus 4b. Minus 6 equals to 0. So again we can see I have 2 common in this. Let's take it out. That is a minus b minus 3 equals to 0. Because if 2 is out, this a will come here. So for 4, 2 is already out. So this should be, minus 2b. And for 6, we will be left with 3 only. So this 2 will shift to other side and this will become 0 again. 0 by 2 is 0. So our second equation is this thing, that is a minus 2b minus 3 equals to 0. So this is our second equation. So now after this step you are free to use any method to find the solution of these two variables a and b, because they have not specified that which method we should use. So here I am directly getting a as 5b. I will substitute it here to find the value of b. So I am using substitution method here. So this will be 1, this as 2. So put value of 1 in 2. So put 1 in 2. So a is 5b minus 2b minus 3 equals to 0. So 5b minus 2b is 3b. So 3b, this minus 3 will go to other side. So this is equal to plus 3. Then what is the value of b? This is 3 by 3 as 1. So we got value of b as 1. Once we have value of b, we will substitute it here and value of a will be 5 times 1, that is 5. Therefore, a equals to 5 into 1. This is 5. After you get the value of a and b, you will write that for a equals to 5 and b equals to 1, this pair will have infinitely many solutions. Okay? So we will write for a equals to 5 and b equals to 1, this pair will have infinitely many solutions. So I repeat what we have done. We need to find the values of a and b so that our given pair will have infinitely many solutions. For infinite many solutions, we need the condition that is a1 by a2 should be equal to b1 by b2, further should be equal to c1 by c2. We have found the values and put the values of your a1 by a2 here. Okay, and then take first two terms to frame one equation in terms of a and b. Take second and third term to frame second equation. Then after you are done with your equations, use any method to solve them, and whatever value you got, that is your final answer. So this is very important type of question. I hope this is clear. Now let's see the next one. So second part of second question is, for which value of k will the following pair of linear equations have no solution? Okay, so this pair is given to us. So what should be my first step? Again, make right hand side 0. So we can write 3x plus y minus 1 equals to 0. So 2k minus 1 times x plus k minus 1 times y minus, again this full term should be put in bracket, equals to 0. So now for no solution, again we need to find the ratios of a1 by a2, b1 by b2 and c1 by c2 first. So let's find the values a1, a2, that is coefficient of x, this is 3 and 2k minus 1. b1 and b2 is, b1 is 1, b2 is k minus 1. Now c1 and c2 is minus 1 minus of 2k plus 1. So now what is the condition for no solution? For no solution, a1 over a2 should be equal to b1 by b2 but should not be equal to c1 by c2. So let's put the values. So here a1 by a2 first, that is 3 over 2k minus 1 should be equal to b1 is 1 over k minus 1, okay, and c1 by c2 is minus 1 over minus of 2k plus 1, but here it is not equals to. Now let's understand this. If we use first two terms, we will get that value of k which when we substitute will have no solution, means k should be equal to that value. Okay, but if I take last two terms, here also I can find one value of k, but that k should not be equal to that value, so that this pair will have no solution. So let's see, I am taking these two terms first. So 3 over 2k minus 1 over 1 over k minus 1. So now cross multiply these. Okay, so this is 3 times k minus 1 is equal to 1 times 2k minus 1. So open the bracket, this is 3k minus 3, 2k minus 1. Shift k term to one side and constants to other. So minus 2k here, minus 1 is already here, this minus 3 will become plus 3. So 3k minus 2k is equal to k minus 1 plus 3 is equal to 2. So means for k equals to 2, this will have no solution. Okay. If I use these two, then it will be for k not equals to that value, then we will have this equation. But since they have asked for which value of k, so this is the value of k for which this pair will have no solution. So we will write therefore for k equals to 2, this pair will have no solution. So again this is also important type. So both parts of second question are important. Okay. So I hope now this type of question is clear to you. That is how to find the values of variable satisfying certain conditions. If you like my teaching, please subscribe to my channel. This is all about this video. See you in my next video with the remaining questions of this exercise. Thank you.